Hello, so today we're thinking about day and night with our space topic. So there's something in your pack that's going to help you. I wonder if you can have a think about what that thing in your pack might be that will help you represent one of these things in a minute. So the lesson is about how we have daytime and nighttime and about the apparent movement of the sun across the sky. So first of all, the question is, does the sun move? Now, I wonder what your answer is to that question. It certainly looks as if the sun moves, because when you look up, you'll see the sun apparently move from one place to another. So here are some questions for you to think about. Have you noticed how shadows change throughout the day? Why do you think that is? So the sun actually stays in the same place in relation to the earth. Do you remember we said in our previous lessons, the sun is the centre of the universe, of the solar system, for us. So it appears to move, but that's because of the movements of the earth as it orbits the sun. So the sun is not moving, it's the earth that is moving. The earth orbits the sun. So how does the earth move? And we've covered this a bit already. So it revolves, which means it orbits the sun. And we've said that one revolution takes just over 365 days, which we know is a year. And that it rotates or spins around once every 24 hours. And that's what gives us day and night. So the revolution of the earth once every 365 days causes the seasons, and the rotation of the earth once every 24 hours causes night and day. So I wonder if you're thinking now what's in your pack that might help you show this. So the earth rotates on its axis. This is an imaginary line that runs from the North Pole to the South Pole. Imagine you're spinning a basketball in your finger. Your finger is where the axis is, and the basketball is earth spinning. So one spin is one rotation, which is 24 hours, which is one day. So have you ever noticed that a globe is slightly tilted? In most globes, they'll be going, you think, oh, that's not straight, it should be straight up. But it shouldn't be. And that's because the earth itself is slightly tilted on its axis. So currently this tilt is 23.5 degrees, but this can change over thousands of years. The rotation of the earth creates different time zones around the world. And when it's 9 a.m. in the UK, it's 6 p.m. in Sydney, Australia, and 1 a.m. in Los Angeles in the United States. So I wonder if you can think about what it is in your pack that might help you demonstrate this. So hopefully you're thinking it's the torch, the lovely torch that you've got, and the batteries in your pack. So I need you to get out your torch, and I need you to get, if you've got a globe, you can get your globe out. And if you haven't got a globe, something spherical. So it could be an orange, it could be a ball. And I want you to show me in either a video or a photo clip about how you can show that sometimes it's daytime for some parts of the Earth planet and sometimes it's nighttime. So have a think, how can you show that using your torch and a ball or a globe? How can you prove that when it's daytime here, it's nighttime in Australia? So with your lovely torch that you've got in your pack, here I've got a globe and I've stuck on a little person in Great Britain, and I'm shining the light here. So you might be able to see his shadow. At the moment he's got a tall, long shadow and he's in daylight. But the people in Australia, down the other side, there will be in darkness, so it will be night. And as you turn, remember we're turning the earth because it's the earth that's moving, not the sun. So keep your torch still. And as you move the earth, day turns into night, and you can see his shadow changes and lengthens. And then as it spins round, Great Britain will be in the darkness, daytime over China, and going round, daytime over North America, back round the next day, and here he is back in the sun. So if you haven't got a globe at home, I'm hoping that you will have a ball. I'm sure we've given you balls in your packs before, and we know you've got the torch. So the same thing applies. Half of this ball is in the light and this half is in the darkness. So here it would be daytime, here it would be nighttime, and remember, it's the earth that's moving, the sun is staying still, and you can still demonstrate it like that. Once it's gone round the whole turn, that's been 24 hours, and that's the day. So I'd love to see your videos or your photos of how you've shown that you know that it's the sun that stays still and the earth moves to create day and night. So once you've done your experiment and you've had your torch and you've got a ball, I want you to complete this sheet, which will be in your pack. But if not, if you haven't collected your pack or you can't find it, you can write this up in your book. So the question is, why do we have day and night? There's a picture of the sun and the earth. Now, the question 1 is, can you explain why we have daytime and nighttime? I've put in a word bank for you there. And then I want you to colour in the picture to show which part of the earth is in daytime and which part is in nighttime. I'd also love it if you could send in some videos or some pictures of you using your lovely torches